So just taking a look at the website as our starting point. Um, I'm still in this section here. This is actually the last section, to be honest. So I have updated these slides here yesterday. So I just want to continue on working my way through those slides, and there'll be a few more that I'll need to add to that deck. And the lab is this one here, which I'll talk about a little bit at the end. You probably have already started it. You should have started really by now. If not, then you should certainly start into it straight away. And I did mention to you before that this lab is essentially the starting point for the second assignment. And I hope to give you the specification and talk through the second assignment next week. So I'm going to open up these slides here. And you may remember the area that I was looking at was what it's kind of an old-fashioned name, I suppose, but it's this thing called messaging within an application. The idea was that when you have two or more compute components, now what does compute components mean in the context of what we've been studying? It means two lambdas. But two compute components could also be two completely separate applications. Um, when those two compute components want to communicate with one another, they can do it directly or synchronously, um, which means that if you've got compute component A and B, and A wants to compute with B, it sends a request, let's assume it's across a network, to B, but it waits for B to respond. And when the response comes back from B, hopefully, then A completes its computation. Now, that kind of synchronous or direct communication, okay, it's fast, but if there are problems with the network, or if for whatever reason compute component B is not available, it could have temporarily crashed. If it's not available by whatever means, that means that stalls component A, and it has to wait until B is available again. So that's problematic because that now means that A cannot complete whatever transaction it's supposed to be completing. So with that kind of direct communication, or it's often referred to as tight coupling, we like to try and minimize as much as possible. Sometimes you can't, you have to allow it, but we try and avoid it. And the way we avoid it is by inserting some sort of messaging infrastructure in between A and B. And so now we say that A and B communicate asynchronously, because what happens is A places a message into this kind of middleware infrastructure, and B, at some stage, it doesn't have to be immediately, but at some stage, B reads that message and processes the message. Maybe B also puts a message into the middleware infrastructure for the purpose of A to pick it up. That may or may not happen. That was kind of the context for the last two lectures, I'd say, really, that we had before we broke for Easter, and that's where we want to try and pick it up. When we bring in AWS into this whole picture and we talk about messaging, then there are a number of services that provide this facility. The two that we're looking at are down on the bottom right here, SNS and SQS. And I mean, from the slide here, we're kind of indicating that these facilitate communication between your compute components, which are your logic components, whatever you want to call them, which as I said, in our case, are lambdas. And I did mention to you, you may have missed the point though, but these two services, SNS and SQS, they predate Lambda. So they were, I think they were probably one of the first, SQS was one of the first services that the AWS platform provided before anything, before DynamoDB, before API Gateway, before Lambda for sure, even before EC2, I think it predates that. And what it was aimed at, SQS, was it was aimed at allowing two completely separate applications to communicate with one another asynchronously. That's a long time ago, though. We now see SQS and SNS used mainly within an application where that application's logic, if you like, is distributed across a number of lambdas. Um, and okay, it also has this serverless aspect to it. SNS and SQS are also serverless, even though they certainly predate the term serverless, and they are serverless because we don't have to configure any servers. There are SNS and SQS servers in the background doing all the work for us, but we don't have to worry about configuring them, starting them up, shutting them down, restarting them, any of that. The AWS platform takes care of all of that for us. And sorry now, I'm not sure if that thing is popping up in front of you. Okay. The first of the two that we looked at was SQS. I know now I'm going back over ground that we've already covered, but I'll fast forward in a few minutes. Um, and you might remember the idea of the language of SQS. We talked about uh, producers and consumers. So the producer is your compute component that is writing a message to your SQS queue, and the consumer is the compute component that is reading messages off of the SQS queue. And these two are not synchronized in any way. So there may be a number of messages written to the queue before the consumer decides to check to see, are there any messages in the queue? The consumer polls the SQS service asking it, are there any messages in the queue? The consumer is not triggered when a message is added to the queue. Okay. If that was the case, then we're back to square one, really. We've got synchronous communication going on between our producer and our consumer. So this was one characteristic of SQS. The consumer periodically polls the SQS service asking it, are there any messages there for, are there any messages there? It's not so much, are there any messages there for me, but are there any messages there? And if there are, then the SQS service um, will send a batch of messages to the consumer for processing. There may be other messages, but it will just batch them and send a subset of them. So this idea that the consumer receives a batch of messages, sometimes that batch maybe consists of one message, but it's still represented as a batch, and the consumer has to uh, kind of extract it as a batch or process it as a batch. Where we see this a lot is where we've got two lambdas that want to somehow communicate with one another, but they're going to do it via the SQS service. Although we didn't have a direct example of that. This SQS service is highly scalable. It does persist the messages for a short period of time. It's certainly not a persistence technology like DynamoDB or anything like that, but it will persist them for a period of time. The max is 4 days. That's just in case the consumer, for whatever reason, is not available. But if it's not available over a longer period than the 4 days, then the messages really get lost. Um, that's okay. Uh, skip over that. Obviously, there's lots of security there, as in the producer, the component that writes messages to the queue, it has to have the appropriate IAM permissions to do so. That's taken as read. It may not be obvious, but if we go back to this little picture here, um, you might think that this lambda, this is Maria representing a lambda function here, and it's receiving messages off of the queue. This lambda service actually doesn't need to have read permissions on the queue because the way lambda works is it's not the lambda function, it's the actual lambda service that checks to see are there messages in the queue. And if there are, then the Lambda service will receive a batch of messages and the Lambda service will send the batch of messages to your Lambda function. Okay. So the Lambda function receives the messages from the Lambda service. Therefore, the Lambda function doesn't need to read the messages directly from the queue. Therefore, it doesn't need read access to the queue. The Lambda service does need read access. Okay. Okay, that's just by the way. Let's go over, skip over that, skip over that. We had an example and I talked my way through that, and you can go back and look at the video if you need to remind yourselves about it. SQS is going to be an important part of the second assignment now, so but you'll be doing it in the lab anyway. Skip over all of that. It's okay. That's okay. If the message is a JSON structure, then that JSON structure will be serialized or stringified, and therefore it has to be parsed by the consuming lambda. And I have examples of that in the lab anyway. Let's keep going. Is that's okay? And the scalability I talked my way through that. And again, go back and look at the previous lecture if you need to. Just going to keep going really on to dead letter queues are an important part of the SQS service. They're important, A, because they're important, and B, because it comes into the assignment. The idea with a dead letter queue is, if we look at the diagram, I guess, here's our consumer. This is let's supposing in our case, this is going to be a lambda function. And okay, it's via the service, but it's checking if there are any messages in the queue. This is my queue here. And it receives a batch of messages. And this is representing my batch of messages here. And it processes the batch. Now, if for whatever reason the consumer cannot process the batch, maybe one of the messages is invalid, and that causes my consumer to throw an exception. Or maybe it doesn't, whatever amount of CPU power has been allocated to the consumer, it cannot process all of these messages in time. In other words, it times out. Whichever reason, the consumer cannot process the batch successfully. When that happens, the batch of messages are actually put back into the queue again. Although really what happens is this batch of messages are temporarily made invisible in the queue. And if the consumer does not process the batch for whatever reason, then that set of messages are now visible again. And my consumer comes along and it polls the queue for messages, it will actually receive the same batch of messages again. Maybe not the exact same batch, but it certainly will at some stage receive the same messages that caused it to crash earlier. Now, maybe like if the crash, if it caused the consumer to not be able to process the batch because it timed out, that could just be a combination of a networking thing or whatever virtual machine or actual hardware the Lambda was running on was extremely busy at that period of time, which means it may be able to process them subsequently. But um, at some stage we have to, let's supposing on the second try of processing this batch, it fails again. And so it'll keep on happening. Okay, it'll keep on receiving the same batch of messages time and time and time again. And clearly that's not clever. We have to put a stop to that. And that's where dead letter queues come into the picture. So what you do is when you configure your SQS queue, as part of the configuration, you indicate that you want to associate with this queue another queue. This queue here is also just an ordinary SQS queue, but its role is to act as a dead letter queue for this queue. And so the way an SQS takes care of handling this now, what you can say in your configuration of this queue is, I'm going to allow my consumer two attempts at processing a batch of messages. And if it fails on the second attempt, then I want that batch of messages to be written into this queue here and deleted from this queue. And the SQS service will do that for you. All you've got to do is tell the SQS service how many attempts do you want to give the consumer at processing a batch of messages. In my case, in the lab, I think, well, I think I get you to change it once or twice, but I guess as far as we're concerned, one attempt is enough. If our Lambda cannot process a batch of messages on the first attempt, then I want that batch of messages to be put into a dead letter queue. And I demonstrated that in the lecture again. Keep saying, referring back to previous lectures, but so go back and look at it. But it does come into the lab, and it also comes into the assignment. So that's dead letter queues. That's okay. DLQ example, we had all of that. And eventually, that's as much as we covered on SQS. Obviously, there's an awful lot more, but time doesn't allow us. So then I moved on to SNS, and I started talking about this at the end of the previous lecture. Now, with SQS, you can have multiple producers writing to the same queue. That's fine. We don't have examples of that. We tend to have one producer writing to the queue, but you can have multiple. You can also have multiple consumers linked to the same queue. But the way the SQS service works is if one of those consumers receives a batch of messages and successfully processes that batch, then none of the other consumers will see that batch of messages or will get an opportunity to process them. Okay, that's the way SQS is designed to work. What if you actually want all of your consumers to see all of the messages? You want each consumer to be able to process every message. If that's what you want, then don't use SQS, use SNS instead. And I think I made that point in this slide here. So the language of the terminology is slightly different. In SQS, we talk about producers and consumers. In SNS, we talk about publishers and subscribers. Okay, or pub/sub for short. The publishers can be a number of things. It could be a Lambda, which will be, publisher could be a Lambda, could actually be S3, which is something that we do in the lab. It could be CloudWatch, and there are other options as well. The consumers can also be varied, and we talk about that in a couple of slides, I think, but typically it's a Lambda. And also very common is to have an SQS as a subscriber to an SNS. A subscriber is somebody that receives messages from your SNS service. Let's see. SNS features, similar security features are similar. It's highly scalable as well. It does have a DLQ option to it, but it doesn't work in the way you think it does. I think I'll talk about that a little bit later on. Whereas in SQS, we talk about queues. We put messages into a queue. In SNS, we talk about topics, also referred to as channels. So we write messages to a topic or to a channel. And that's what the picture shows us here. So in this case, I've got one publisher, although again, you could have many different publishers writing to the same channel. And on the right, we have our subscribers. And as I was saying there at the outset, well, there's 2 points being made by this image. There are different types of subscribers. At the top, we have Lambda could be a subscriber, SQS could be a subscriber, an API gateway, which is what I mean by that. That could be a subscriber. And there are other ones as well, which we won't get a chance to look at. But if you've got a number of subscribers, then every message that, let's say, this publisher writes to a topic, each of the subscribers will get to process that message. That is the way SNS works, and that's the way it's meant to work. Right. This is where I left off. How far are we into the lecture? This is where I left off the last day. Let's have a simple example of using SNS. And the architecture of our example, we're just using the AWS CLI as our publisher, just for convenience. We have an SNS topic, and we've got a Lambda function as our subscriber. Yeah, this is how we write the infrastructure code. So this is how you create a topic. Pretty straightforward. There's no configuration at this stage anyway of our topic. Our subscriber is a Lambda function. We know how to create a Lambda function, so there's nothing special in terms of the configuration of the Lambda function. This is how we connect up a subscriber, i.e. our Lambda function, to our topic. So we add a subscriber. And in our case, the subscriber, its type is a Lambda subscriber, although there are other options here that we can use. And in particular, we're saying this is the Lambda function that we want to be the subscriber. And I'm outputting the topics ARN Amazon resource number because my CLI will use that to publish messages. This is using the CLI. This is how we publish messages to a topic. This is the subscriber Lambda function. So its type is the handler type is SNS handler, and it's similar to an SQS consumer in that it receives a a batch. Now, I'm trying to word this in a way that um, well, it seems like it receives a batch, but it doesn't actually. Okay. I'll explain that a little bit more in a while, but you can see here, I'm looking at the event object that is being passed to my Lambda function, and I'm indexing into, so this is the event into the records property, and which is an array. So that suggests maybe that my Lambda subscriber is receiving an array of messages from the SNS topic, but I'm just focusing in on the first message in that array. For now, I'll just say that's just because I know that there is only going to be one message in the quote unquote batch that it receives. That's why I'm hard coding it to pick up the first message in the array. And I don't do anything interesting with it. Okay, I just check to see does it have a particular property, get it to throw an exception if it doesn't. Otherwise, I don't do anything other than that. Right. So if I go over to VS Code, there's been terribly exciting now in demonstrating this, but I will demonstrate it anyway. So this is if I look at the infrastructure code, this is what I was just talking my way through there. Here I create my topic. I've commented out some stuff because I'll bring those in a little bit later on. There's my topic. There's my Lambda. And here's where I connect up the Lambda to the as a subscriber. And I just output the topics ARN. So I've already deployed this. Let's confirm that. There it is there. And this is the topics ARN. And let's send the message to, so if I grab that topic ARN, and the message that I'm sending, let's look at the message. Okay, that's my message. So because this is my Lambda here, and it's console logging, so there should be a CloudWatch log stream, hopefully. So let's go over to CloudWatch. And as always, it's a good idea just to look at the structure of the event object, which looks like this. And let's see, where's the body? I guess that's just there, is it? Yeah, that's it there, yeah. That looks about right based on the message that I sent. Okay, so pretty simple. And here's, so this is the entire event object. It has a records property, which is an array. Okay, and that's how I treated it in my Lambda. So it seems like a potentially my Lambda subscriber receives an array of messages based on looking at the structure of that anyway. So we'll accept that for now, but turns out not to be the case though. All I'm showing down here is if I go over to VS Code, this kind of proves that you can have different types of subscribers. So all I'm showing you in the screenshot there in the slides is if I do, oh yeah, here, as I'm writing this code, if I go dot, these are the different types of subscribers that you can have. You can have a Lambda subscriber, which is what we're using. You can have an SQS subscriber, which we will use a lot of as well. You can have a HTTP, well, it's calling a URL subscriber, but that could be a number of things. But in our case, that could be an API gateway. The other two, then, the email subscriber, you can actually trigger the sending of emails as a result of a message being published to an SNS topic. We won't get an opportunity to see that, but you can. Or you can trigger the sending of an SMS message as well. Okay, so that's fine. Back to my slides. And maybe I'll just, let's let it run for a second. Um, Okay, I've demonstrated that to you, so I don't need to talk my way through that. So this is a very common pattern now when you're using the SNS uh, service. It's called the fan out pattern, and what it what it's trying to illustrate is when uh, um, you you can have I've kind of already made the point though, but you can have a number of subscribers linked to the same topic, and each of those subscribers will get every message that's written to the topic. I've kind of already made that point, I know. But that is a technique that we use quite a lot when we're developing applications that use SNS. It's almost rare to have just one subscriber linked to a topic. If that was the case, the topic might not be the best choice. Maybe you should use SQS instead. But if you've got a number of, let's call it, if you've got a number of things that you want to happen in parallel whenever a message is written to a topic, then uh, the way we would implement that is by having this fan out pattern. Now, from the screenshot here or from the image, it's suggesting that the each of my subscribers is an SQSQ or has to be an SQSQ, but that's not the case, right? You could have a combination. So the subscriber can be an SQSQ. Of course, there's going to be a lambda over here that's feeding, that's consuming the messages that are being written to that queue, and the messages will be written by SNS. This one might be a lambda itself directly. This one down here could be an API gateway. We could have another subscriber that's another SQSQ. So you can mix and match the subscribers that are linked to one SNS topic. Although a a pattern that we see a lot is where most, if not all, of the subscribers are SQSQs, which are linked to lambdas. The lambdas, which would be over here, these lambdas, though, they're not subscribers. Okay, it's the SQSQ is the subscriber. The lambda is just an ordinary queue consumer. And so we've got an example of that that I just want to talk about. And well, let's go back here, and I want to destroy that stack. And I want to deploy another one. So where is the other one? Let's see. And this new stack now will illustrate this kind of fan out idea. If I can find it. Just want to leave the destroy complete before I pull in the code, because sometimes if you modify the code as it's being destroyed, it can cause problems. Okay, that's done. And I'm going to deploy this. So the stuff that I'm deploying is has this architecture here. Again, I'm just using for convenience the AWS CLI as my publisher, and I've got two subscribers. So this is an example of fan out. One subscriber is a Lambda function. The other subscriber is an SQSQ, and that SQSQ also has a consumer, which in my case is a Lambda as well. So that's my architecture. Here I'm showing you excerpts from the stack code itself. Um, so I create my topic, my SNS topic. I create my queue. Nothing special about that. I create a Lambda function, and just based on the name, this is the Lambda function that is essentially this one here. It's going to be a direct subscriber. I've got a second Lambda function. Well, I haven't shown it here, but I do have a second Lambda function that is the consumer for my queue. Neither of the Lambdas do anything interesting. They just do console logs. Here I am kind of hooking up my two subscribers to my topic, although I have to do that individually. So first of all, I'm adding the Lambda subscriber. And secondly, I'm adding the SQS subscriber. So that's the bulk of my infrastructure code. Let's just look at the actual code to see, is there anything additional? Okay, my topic, my queue, my Lambda, my second Lambda, and yeah, there's nothing special now. Sorry, now we don't need that for now. So let's see. Filtering is something that I'll talk about either today or the next day. So we don't need that. And that's okay. And I do also need to uh, connect up my Lambda consumer with my queue, which we did in the previous lecture. That's all that's going on here. Yep. So let's before I trigger writing a message to the queue, if I go into CloudWatch and just as I tend to do, delete any, just going to do a refresh. Let's delete that just for convenience. And I'm going to publish a message to the topic. So let's get the topic ARN. I appreciate now these demonstrations this particular week aren't that interesting, but okay, so this is the same command as before. And if I flip over to do a refresh here of CloudWatch, do another refresh. So this log group is linked to the Lambda that is a direct subscriber to the topic. The other Lambda, which is a consumer to the queue, it takes a few moments for that to appear because there is the message has to be transferred to the queue, and then we have to wait until the Lambda service polls the queue and all of that. So that doesn't happen immediately. Just do another refresh. Still not there. That's okay. That's to be expected. So this is the log stream for, as I said, for the Lambda that is a direct subscriber. And we've kind of seen that already. And the Lambda doesn't do, I didn't look at the Lambdas, but they don't do anything interesting, I don't think. So it's this one here, you know, just as a console log. Okay, it does some error checking, but the message that I sent, let's see, the message that I sent is again my standard little, do I have it there? It is there. No, it's not. Where's message? There, sorry. Okay, my standard message. Let's go back to CloudWatch, see if that second log group has appeared. Another refresh. It would have been there by now. Just leave it there for a while and go back to my slides. So eventually I will prove to you that, you know, this second subscriber did get the message, and the only way I have of proving that is to prove that this Lambda was actually triggered, and the only way it would have been triggered is if there was a message written to this queue. Oh yeah, I'll come back to that in a second. Let's do another refresh. Fingers crossed. Why did it not appear? I'll let that rumble on maybe. The point that I'm making on this slide here is when you've got an SQS subscriber linked to an SNS topic, then what SNS does is it wraps the message in what's called an envelope. And the envelope contains some extra metadata, which may or may not be of interest to you in your application. So what I'm saying is, when you've got this connection here, an SQS subscriber uh, to a topic, the message, which in my case, the message originated with the AWS CLI, but in the lab, for example, the message originates from the S3 service. Either way, that message, when it is before it's sent on to the SQS queue, uh, the SNS service will wrap the message in what's called an envelope. Now, sometimes that envelope contains useful information. In many cases, it doesn't. And so you can optionally configure your SNS topic such that that envelope is discarded. Okay, and so what's written to the SQSQ is the actual raw message that was published onto the SNS topic, and that is what the Lambda receives, that kind of raw message. Yeah. Now, the way you disable or enable the inclusion of the envelope, it's part of the configuration of the SQS subscriber itself, and that's what I'm showing you here. So it's this property, raw message delivery. So if you set that to true, then you're saying, I do not want the envelope to be included. And when you look at it in CloudWatch, this is this screenshot now is from the CloudWatch of the Lambda that is the consumer of your SQSQ, this kind of Lambda here, right? Um, uh, in this screenshot, we are showing you if this is our original message that we published to the SNS topic, then you can see that the message is here, right? But everything else in the body is this envelope. Okay, so there's quite a lot of extra data that's included in the envelope. Whereas if you configure the SNS topic to not include the envelope, then the body of the message that's received by the Lambda looks like this. Okay, so the body is where are we? Here's the body here. Okay, and it's much smaller. So that may be significant if you've got a high volume of messages and you know there's nothing useful in the SNS envelope for your Lambda consumer. The Lambda now is the Lambda that's consuming the messages from the SQSQ. It's not a Lambda that is a direct subscriber to an SNS. Okay, it's a bit confusing, but that's the way it is. So that's the point that's being made by those two slides. Let's just go back, and if it doesn't work for me this time now, I'm just going to park it and get back to you as to why it didn't work. So I'm going to take my SNS topic, ARN, copy that, paste it in there. Now I'll just leave it there for a few moments. I'll keep on with my slides. Um, what can be confusing is it looks like there are two options here, right? From the Lambda perspective, you can have a Lambda that is a direct subscriber to an SNS topic, or you can have an SQSQ that's the subscriber, and then have a Lambda that is the consumer to that SQSQ. Okay, so the question is, which option should you pick, or what are the advantages or disadvantages of one approach, one pattern over another pattern? And that's what I'm just trying to explain here, just for completeness, really, even though you won't be in a position where you have to make this kind of decision. So I'm saying the disadvantages of when you've got a Lambda as a direct subscriber to an SNS topic. You don't have any batching. Did I actually, sorry, can I go back for a second or two? Boom, boom, boom. Oh yeah. Um, sorry, no, I skipped over this slide. What I'm saying here is, sorry now about this. This is when you've got a Lambda that is a direct subscriber to an SNS topic. And I've already kind of shown you in the Lambda function itself, it looks like that potentially your Lambda subscriber receives a batch of messages from SNS, but it never does. It's always a single message. And so that's why here in the actual text I've written, a Lambda subscriber receives a batch of messages, and I've striked out batch of messages because that is not the case. At least from my reading on the documentation, it never receives a batch. It will always receive only one message uh, at a time, if you like. And so that means, if I go back yet again, sorry now about this. What it means is that every time a publisher writes a message to a SNS topic, and let's suppose you've got a Lambda subscriber to that topic, for every message that is written to the topic, that message will trigger an execution of your Lambda. Each message will trigger an execution of the Lambda, because in the case of SNS, it's SNS tells the Lambda, SNS triggers the execution of your Lambda. Whereas when you've got SQS here in the middle, Lambda holds the SQS service, so it's all initiated from the Lambda side. Whereas with SNS, the event is initiated from the SNS side. So for every message that's written to an SNS topic, that will cause the SNS service for each message to trigger an execution of your Lambda instance. Yeah. So that's that's why in my code I'm always go back to my code, jumping around the page a little bit too much now, but so in this case here, this is the Lambda that is a direct subscriber. And in this one, again, I'm always just picking out the first message in the batch because there is never more than one message in a batch which is received from an SNS topic. Right. And before I move off it, now if it doesn't work this time, I'm just going to park it. Just going to do a that and a refresh. And there should be one. Let's see. There we go. At long last. So that hopefully. Oh, look, there's actually two of them. uh, Now I've only sent one message since I redeployed, but there are two log streams here for two lambdas. And this is just one of the quirks of, well, when you're working on a network, really, I suppose, and also when you're using AWS, your log streams won't be updating as quickly. Sometimes they may not update as quickly as you'd like them to. And I think that's really what happened there when in my previous deployment, the log stream just wasn't uh, being received and processed by CloudWatch quickly enough for us. Anyway, so we can now see, I can confirm that these two here, these are log groups related to my Lambda, which is a consumer to my SQSQ. And that SQSQ is a subscriber to the topic. It's all a bit confusing. Let's just click through it just to confirm that. So this is an SQS Lambda. And, here's the event that it received, which looks very like the event that a Lambda, which is a direct subscriber, receives. And eventually we can see in the body, we can see our message. Yeah. Let's see. Oh, yeah. That's our message. That's our message minus the envelope that I was talking about there. Yeah. Because if you look at my code, sorry, now this probably is, I haven't lost you, but if you look at my configuration code, and if you look at the SQS subscription to the topic, which is this one here, you can see I've specified that I do not want the envelope to be included. Yeah. If I set that to false, then you would see the envelope in the body of the message that's received by the Lambda. And you can play with that yourselves. Okay, let's get back on track. So hopefully I have shown you this working where I've sent a message to the SNS topic and I've shown you via CloudWatch, I've shown you that this Lambda was triggered, which we would expect because it's a direct subscriber. And I've also just shown you that this Lambda is also triggered eventually. Okay, that's that. I've talked about the envelope idea. It's not a big thing, this envelope idea, but I think as far as you're concerned, you would always set this to true, as in you do not want the envelope because it contains unnecessary information. And I was about to explain the difference between these two approaches, whether you have a Lambda that's a direct subscriber or have a Lambda which is eventually triggered from an SQS subscriber. When you've got a Lambda that is a direct subscriber to SNS, you don't have any batching, which hopefully I've demonstrated anyway. There's no such thing as proving. That's just the way SNS works. There's no batching. So that means that, if you've got a high volume of messages being written to an SNS topic and you've got a Lambda that is a direct subscriber to that topic, then you've got a high volume of Lambda instances being created. Okay. And each Lambda is just only processing one message. So there are cost implications associated with that. There's no control on Lambda concurrency. Yeah. Unlike with SQS, we can control how many SQS Lambda consumers are triggered in parallel. You don't have that power with SNS. Uh, uh, there's no uh, there's no DLQ available to us here as there was with SQS. Okay, so there's no easy way of handling. Well, sorry. Let's just leave it at that. There's no DLQ option available to us. There is a way, though, of handling the situation when your Lambda actually fails. If it throws an exception, we can't just leave it at that. Okay, it receives a message from SNS, it processes the message, but as part of that processing, it actually throws an exception. We still want to be able to somehow formally deal with that particular message. And I'll show you how to do that in a moment. But we cannot do it via this kind of DLQ idea. The alternative approach is where you have SNS, the advantages of having a Lambda as a direct subscriber to SNS is really performance. So if the messages that are being written to an SNS topic, if you want a Lambda to be triggered immediately and process that message because it's time critical, then that's a good case for having a Lambda as a direct subscriber to SNS. If you don't want that, though, you should take the approach of having SQS as your subscriber and then a Lambda consumer linked to that. Okay. So the nice thing about SQS is this whole DLQ is kind of built into it, whereas you don't have that with SNS. But because we're operating across a network, there will still be cases where a message is written to an SNS topic. SNS tries to pass that message on to its various subscribers, but for whatever reason, typically networking, it cannot deliver the message to some or all of its subscribers. So what should happen? Well, the way SNS works is it actually keeps on trying quite a number of times until eventually it gives up. But it has a number of tries at delivering the message to its subscribers before it eventually decides to give up. And that's just built into the SNS service itself. So I'm saying SNS, it defines what's in the language of SNS. It defines a delivery policy for each delivery protocol. Now, by delivery protocol, I mean for each type of subscriber. So it has a policy of retrying to deliver a message to a subscriber depending on the type of subscriber. The policy defines how many SNS retries it attempts before it eventually gives up. And if it does eventually give up, you can still configure SNS to put those messages into a DLQ, although I won't demonstrate that. Okay. I took this directly out of the SNS documentation, and we're only interested in sort of this part here where our subscribers, they're what are called AWS managed subscribers. So that would be Lambda, That would be SQS. They're the two that we're interested in, but there are other managed subscribers as well. And you can see here that, it really tries a number of times. So first of all, it has 3 attempts at trying to deliver a message to a subscriber. And those 3 attempts are in immediate succession. So there's no delay between them. So there's 3 goes at delivering the message. If still it cannot deliver the message, and the way it knows whether the message has been delivered or not is because it will get an acknowledgement from the subscriber service that the message has been received. So that could be the Lambda service tells it, I received your message, or the SQS service responds to SNS saying, I have received your message. If it doesn't get any positive response back from the subscribing service after three attempts, then it will try 2 more attempts, but it will have a 1 second delay between each of those. If it's still not getting any success, it has 10 more attempts with what's called a back-off algorithm delay between each of the 10. And it actually has a number of other attempts. So it doesn't give up easily, as I said. And so if after all these attempts, it still fails, now I can't simulate this because really the failure to deliver would be down to networking issues, particular availability zone is not contactable, that kind of idea. So the overall message is it tries bloody hard to deliver the messages to its subscribers before it eventually gives up. If you've got a Lambda that is a direct subscriber and you have a case where the DLQ there is probably misleading. I should have written something else really, but okay. If you've got a Lambda that is a direct subscriber, and for whatever reason the Lambda throws an exception, or fails, maybe crashes as it's trying to process the message, you can configure the Lambda to do something with that message. And the way you do it is through this on failure configuration of the Lambda itself. Okay. And in this example, I am indicating that because in my case, this is the Lambda that is a direct subscriber to my topic. And I'm saying if it fails, i.e. if it throws an exception or times out, then I want the message to be sent on to an actual, maybe DLQ isn't a bad idea, actually. Sorry, isn't an inaccurate heading here. I'm saying I want the message to be written to a particular SQSQ. And that SQSQ is really acting as a dead letter queue for this Lambda. But I'm configuring the dead letter queue as part of my Lambda configuration. I'm not configuring the dead letter queue as part of another queue. So the net effect is the same though. Okay. So you can actually have messages that cannot be processed by your Lambda. You can have them written to another destination. In my case, I'm picking a queue as the destination. This now again is when your Lambda is a direct subscriber to an SNS topic. If your Lambda is, let's see, is this Lambda here, because this Lambda is linked to SQS, then you can have your traditional DLQ operation there. The type of Lambda I'm talking about is when your Lambda is a direct subscriber to your topic. If this Lambda fails, throws an exception, then what I've shown you in the code is you can have the message sent somewhere else. And in my case, I had it sent to an SQSQ. Yeah. had it sent to an SQS queue, which presumably there would be a Lambda that would be processing the messages in that queue, finding out what was the fault with the message, etc. Okay, so because really, when you're doing any kind of AWS development, you have to be aware of the fact of uh, errors occurring within your application, and you have to handle those errors. You can't have a case where, let's say, this Lambda here crashes, throws an exception while processing a message, and we never find out, well, what what happened to that message? Was it ever reprocessed or reported to somebody appropriately? Okay, I'm conscious of the fact that I lost a lot of time there now on that demo. Okay. So I'm not, even though I have a demonstration of this, I'm not going to demo it, but the code is pretty straightforward, I think. Sorry, just give me a second. Sorry, no. Okay. Actually, I've got a little bit more time than I thought. Let me demonstrate what I've just been talking about there. So again, I have to do a destroy. Oh, sorry, no, it's the same stack actually, I think, isn't it? No, let's do a destroy. CDK destroy. And let's look at another application that's demonstrating what I've just been talking about. Okay, here we've got a topic, SNS topic. I now want to actually enable this. I've got a queue, and this is the queue that's going to receive messages that couldn't be processed by my Lambda subscriber. I've got my subscriber and my Lambda subscriber, and here I have configuration for dealing with cases when my Lambda throws an exception. And as I said, I'm sending those messages to my queue. And I've just got a Lambda here that will process the messages in that failed queue. Strictly speaking, it's not technically it's not a dead letter queue, but it's kind of playing the same role. And what else? Ideal queue. Okay, I need to link up my Lambda that's processing the messages from the queue, which is what that is doing. And I'm just outputting the topic ARN. So my architecture here is I've got a topic which has a Lambda subscriber. That Lambda subscriber, which is this Lambda here, it's a direct Lambda subscriber, but for this Lambda, I have programmed what I want that Lambda to do if it crashes while it's trying to process a message, and I've decided I want to send the messages to an SQSQ. I could have actually specified another Lambda here directly, but I'm saying put it into an SQSQ, and this is the Lambda that's going to process the messages from that queue. Neither of the lambdas do anything interesting. They just do console logs. Okay. Here's the lambda that's the direct subscriber to the topic. And it looks like there's only one case when it might throw an exception, and it is if the message doesn't contain an address attribute. Okay. Uh, so if I do a CDK deploy of this stack, and again, I'll use the CLI to send the message. So here's the message as before. Now, in this case, my message has a name and an address and an email property. And the only case when my Lambda subscriber throws an exception is if the message doesn't contain an address. So I guess let's just do that straight away. Let's take out that property from my message. And let's also clean up CloudWatch logs while that's going on. Here's my topic ARN. Publish my message, and hopefully CloudWatch will behave this time. Although there will be a delay before the second Lambda because the second Lambda is linked to an SQSQ, and so there's that delay due to polling. Okay, this is the Lambda that's a direct subscriber, but we should see when we look at the log stream now that it throws an exception because the message it received does not contain the address property. And here we can see the exception being thrown. Yeah, I'm getting the bad message exception, which let's go back to the actual code. That's the exception that it throws, this bad message exception. And because my Lambda, at the risk of laboring the point now, but because the Lambda that we're looking at there is linked to this Lambda here, the on failure configuration means that that message that caused the exception is going to be written to my SQSQ, and that SQSQ is being polled by this Lambda. So eventually we should see a log stream for the Lambda that I've just highlighted on the screen there. Again, fingers crossed. Do a refresh. No, it's going to be a delay now, really, again, but I'll just try and I'll push on if it doesn't, and I'll come back to it before the end of the lecture. No, I'll just leave it there for a few moments and I'll continue on with the lecture. Although maybe just before I do that, if I switch for a moment now to the lab, and this is a lab now that you will have to submit. But what we're doing in this lab is we're trying to implement this architecture here. So we've got an S3 bucket, and we are uploading files, image files to that bucket. Now, when an image is uploaded to the bucket, I want a message to be written to an boom, 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 let me see. Um, I want a message to be written to an SQSQ. Okay, this is going back to our stuff on SQS, but I want a message to be written to an SQSQ, and I want a lambda function. This is my lambda function here, which should be triggered periodically based on messages in the SQSQ. And the lambda function actually, because in the message that it will receive linked to the uploading of the file, uh, that message will contain the URL of the bucket and the name of the file, which is referred to as the key of the file. That will be contained in the message that this lambda receives. Okay, we're talking about SQS now as opposed to SNS, but uh, because that's contained in the message, that would actually allow this lambda to access the object in the bucket. So it'll actually read the object. I don't do anything once it's read it. I don't do anything with it. This Lambda doesn't do anything with it, but we do have the capacity to access the image file downloaded essentially locally to the Lambda, and it could process it there if it wanted to process it. Okay, so that's how you kind of link up S3 with SQS with Lambda. So S3 in the language of SQS, S3 is my producer, as opposed to a Lambda being a producer or the AWS CLI as being a producer. Okay, then in the second part, I introduce the SNS. And it's an example of using this fan out pattern that I've been talking about. We're still sticking with the same general idea. User uploads a image to a bucket. In this case, the S3 service publishes a message to an SNS topic. And we have two subscribers to that topic. One of the subscribers is an SQSQ. The other subscriber is a Lambda, it looks like. And these two Lambdas, sorry, the SQSQ also has a Lambda consumer linked to it. So that's quite a sophisticated architecture that you're looking at there. So you see how to hook all of these up. And again, you'll use the AWS CLI to upload an image to the bucket, and then you will go looking at your log streams for the two Lambdas. Hopefully they'll be a little bit more responsive than they have been for me. And mention of that, let's do another refresh here. Okay, got it eventually. I'll come back to that in a second. Okay, so there's a lot going on there, but in particular, the focus is on fan out, the SNS fan out pattern. In the next section, I actually introduced a service I haven't talked about at all called sorry, you have already covered the SES service, the simple email service. Uh, you've already seen that when we were looking at Cognito, if you remember. But what I use SES for is, let's see, is it in the diagram? Yeah, you can see from this diagram here. What this Lambda does is it uses the SES service to send an email notionally back to our user here to confirm that, the image that he or she uploaded to the bucket has been processed. Right? It's kind of a confirmation that the image has been processed by my architecture, or at least that it has been received by this overall architecture. Yeah. So that's what you do in this section. And once you've completed this section, then you can um, submit the URL of your GitHub repo because you're going to be pushing all of this stuff to a GitHub repo. Submit that for assessment. Now I'm giving you all the code. Okay. So it's just as straightforward. Did you work your way through the lab? Yes or no? But you will get marks for it. And when you've completed this, then you have uh, essentially kind of the basis for the second assignment, which I will talk about next week. However, there are two more sections in this lab. So I'm currently looking at this section here, right? But you can see there are two more sections. And it's going to be really important that you cover these two sections as well, even though they're not part of uh, they're not part of the lab that is being assessed, if you like. You can tell from the heading here that this section is demonstrating SQS dead letter queues. So if I just go forward, it's SQS dead letter queues. And really what you're doing here is you're downloading the application that I would have used in the lectures and talked my way through the lectures, but I'm giving you an opportunity to uh, deploy it and essentially kind of play with it. Yeah, otherwise step you through what I want you to do. Hopefully, the intention is that you have a clear understanding of the role of dead letter queues in the SQS service. And then in the next section, we're looking at SNS subscription filtering, which I haven't talked about yet. I'll start talking about it today, and we'll look at it the next day as well. Um, in this section as well, you download a starter pack. Where do you download it? Here, you download a starter application. So I guess this section and this section, um, you could postpone those until next week, but you should aim to complete the first three parts this week and submit it. I think the deadline for submitting this lab is Wednesday week, not the coming Wednesday, but the following Wednesday. Okay, back to the lectures. Okay, let's so what I just wanted to look at was I wanted to look at the log stream of this Lambda. This is the Lambda that is processing the messages that were caused a problem for this Lambda. And it threw an exception and it wrote the messages to an SQS queue. This Lambda here processes the messages from that SQS queue. It doesn't do anything interesting. This is the Lambda itself. There's our standard console log of the event that it received. And what does it do? Well, because this Lambda is a Lambda that is being triggered from SQS, then it is receiving a proper batch of messages, even though in my case there is only one message in that batch, but we shouldn't hard code it to only expect only one message, which is why I've got a standard kind of for loop going through all of the messages. But so this console log here, for example, if we look at the log stream, sorry, which is this one, I think. See, how am I getting that? Sorry. I think that lambda is wrong. There isn't a customer name property, so that's my fault really. So anyway, this is the console log. Why can't I see the message there? Let me see. I should have really, oh, there it is there, I guess, yeah. So that's part of the actual message. And there's only a name and an email. There's no address property in there, which is, that would make sense because that's why this lambda was triggered at all. It's because the message was rejected by the other one, the other lambda. Okay, and we want to prove that the to prove that the first lambda works fine as long as the message does contain an address. You know, if we went back to our message, if we went back to our message and put the address back in, and then send that message. Now, because of the delays with CloudWatch, I won't hang around, but if I just send that message, you know, no matter how long we would keep refreshing our CloudWatch logs, we are never going to see a log stream for the second Lambda for this particular message because the message does have an address property, and that means the first Lambda is not going to throw an exception. Uh, Therefore, the second Lambda should never be triggered. Okay. Sorry now about the slight clumsiness in this demonstrations that are going on today, but that's what happens when you're working across a network. I'm just going to start talking. Okay, so the next thing I want to look at is this fan out pattern. But when we include filtering in the pattern, so the image kind of hopefully gets the message across. So again, we've got an SNS topic. We've got a number of subscribers. Okay, they happen to be SQSQs, all SQSQs, but they don't have to be all SQSQs. Some of them could be lambdas and et cetera, et cetera. We've got some publisher to of my messages, and what's nice about the image, I don't know where I found it on the web, is the messages are kind of color coded, right? Um, and what filtering allows us to do is filtering allows us to control which messages are actually received by subscribers. You can actually filter the messages at the subscription level. So it looks like maybe this subscriber, it doesn't have any filtering, whereas this subscriber only receives, I'm not sure about the color coding now, but it only receives a subset of the messages because we have configured some filtering on this particular subscription such that it only receives certain subset of the messages from the topic. Similarly, there's filtering going on here, doesn't receive all the messages. Same here. But as I said, this one seems to receive pretty much all of them, so there's no filtering. So SNS allows us to perform filtering of the messages before they reach our subscribers. And the filtering is something that you associate with the subscription. There are kind of three components to this fan out pattern. There's the SNS topic, there's the subscriber, and then there's the subscription. The subscription is what links a subscriber to the topic. So how do we actually specify the filtering? So I'm saying here that the filtering can be based either on attributes of the message. We haven't talked about message attributes so far, but uh, a message, as well as a message having a body, the body in the examples that we've been looking at so far, you know, the body, this would be the body of the message, all of the data in the message. But separate from the body, you can attach attributes to the message. And so you can filter based on the attributes associated with the message, or you can filter based on the structure of the body itself and properties within the body. Slightly harder to do it for body properties. It's from a syntax point of view, the attribute-based filtering is easier to program. Although having said that, right, the body property filtering is probably the one that one would use most often. Anyway, there's two bases on which you can do your filtering. Whether it's attribute-based filtering or body property-based filtering, the filtering criteria are the same for both, which I'm just kind of documenting here in a kind of a dry form. And maybe when you see examples, you'll see what we're trying to get at here. So you can have a straightforward string filtering criteria. That would be where an attribute, and an attribute really is just a key value pair, where you want to do the filtering based on the value of that key value pair, where the value is a string. Okay. And in terms of the conditions associated with the string of an attribute value, you can have the allow list, the deny list, or the match prefix. So you can specify a list of values that you will allow to go through the filter, or if it's easier, you can specify a list of values which you do not want to go through the filter, or you can just specify that the value of a particular attribute should have a particular prefix, and if it has that prefix, then allow it through, otherwise don't allow it through to the subscriber. That's if the attribute is a string type. If the attribute is a numeric type, then you have all of these types of conditions that you can associate to specify your filter. Or thirdly, you can have just an exist filter. In the exist filter, you're just saying, well, if a particular attribute is attached to a message, then let that message pass through the filter and go to the subscriber. If it doesn't, then Um, do not let it go through to the subscriber. Examples hopefully will make all of this a little bit clearer, which I think is what we look at next. And that means I have to bring up and do some destroy and redeploy. So let's destroy this stack. Now I've just checked my time, so maybe I should not demonstrate filtering and let it go until the next day. Let me just check. Yeah, so I need to cover filtering the next day, Witchy, and what I'll also do the next day is present the specification for assignment 2, which, surprise, surprise, will involve SNS, SQS, S3, I think, SES, and there'll be some filtering aspects to it as well. Okay, apologies again now for the slight clumsiness in the demonstrations this week, but so be it. I will pause again, just in case there are any issues that you want to raise with me before I sign off. No. Okay. So get working on this week's lab, and I will touch base with you on Friday morning during the lab. Thanks a lot. Bye-bye.